allocation. Before starting what is dynamic memory allocation, we discuss what is memory allocation. Memory allocation is allocating memory to variables. Okay, and these allocation can be done in two methods. One is static memory allocation, other one is dynamic memory allocation. Static memory allocation is memory allocated for the declared variables by the compiler at the compile time. It is done by compiler at the compile time. And this kind of memory is remain fixed. That means the size of memory allocated to a variable remain fixed for the entire lifetime of the program. That means it till it program executes. And dynamic memory allocation is memory allocated at runtime, allocated to variables at runtime. Okay, uh, here we can allocate memory as much as we need. We can deallocate memory if it is not desired no longer. Okay, let us take an example for compile time memory allocation, that is static memory allocation. Suppose I declare a variable int a. What does the compiler do for this? Compiler will find that 2 bytes of memory is required for variable a because its type is int. Okay, then it will allocate 2 bytes of memory taken from the free available memory. Okay, 2 bytes of memory block is allocated to variable a. Then this block is labeled with variable a and has some lower byte address. Suppose is 2000, which can be represented in C by ampersand a. And this memory block can have some contents, which are the value assigned to variable a. Okay, now this is a static memory allocation where the compiler will find how many number of bytes a variable a is required, and that much memory block is allocated to that variable, and this size will remain fixed throughout the program execution. Another way around, suppose I want to declare an array of size 5, suppose. Okay, from this the compiler will come to know a array of 5 elements need to be allocated to variable array. Okay, now as from this data type the compiler come to know that the type each element required 2 bytes, then total of 5 into 2, that means 10 bytes of memory will be allocated to array A. Okay, and it will allocate a block of 10 byte memory containing 5 elements is allocated to a variable array. Okay, but in this case the maximum number of elements that can be stored in this array is 5. Suppose at runtime it is desired to store more elements, desired to store more elements at runtime, let it be I want to store 10 elements in variable array. I can't do this, cannot store, because it is a static memory allocation and the size of array remain fixed. Okay, other way around, let it be I declare, to overcome this, I declare a variable b of size 100. That means the maximum number of elements which can be stored in array b is 100. But at runtime, I am storing only, oh, sorry, how much bytes it will take? It will take 200 bytes of memory for variable b. Okay, at runtime, only 5 elements are stored in array B. Okay, then it will occupy only how many number of bytes? Yes, 5 into 2, that means it will use only 10 bytes of memory. How much memory is wasted? Yes, total 200 bytes is allocated for B and 10 bytes are used. Then we are wasting 190 bytes of memory. Okay, this is the problem in case of static memory allocation. That means if we have declared a variable of larger size, let's suppose in case of arrays, and at runtime we come to know we want to store only few elements, then we are wasting the space. And other way around, if I'm declaring a array of smaller size and at runtime I want to store more elements, I cannot store due to static memory allocation. To overcome these problems, we use dynamic memory allocation. Okay, dynamic memory allocation. Okay, with this we can allocate memory as well as and when required at runtime. To do this in C or C++, there are some functions used for dynamic memory allocation which is used with help of pointers. Okay, these functions are malloc, calloc, then to deallocate memory we use free, and another function we use is relock. For using all the 4 functions, we need to include a header file alloc.h, or you can use stdlib.h. Okay, let us discuss each and every function one by one. First is malloc. Malloc is a function used to dynamically allocate a block of memory of specified size size. That means the number of bytes which is passed through this malloc function, it will allocate a block of that much size memory. Okay, then it returns a pointer. It returns a pointer of type byte which can be casted into pointer of any other type. Pointer of any other type. Okay. Third one is it initializes each block with default garbage value. Okay. What is, let us discuss the syntax of this malloc function. Suppose we have a pointer ptr, let it be of type int star. We want to allocate a memory of 5 elements. Then I say 5 into size of int. Okay, then it will store 10 bytes of memory. As we know, the size of integer is 2 bytes. Then total कितने हो गए आपके पास? This one and this one is 10 bytes. Okay, then malloc, what the malloc will do, it will find a 10 bytes memory, free memory, and allocate that memory to ptr. Okay, if it is not available, 10 continuous bytes of memory is not available, then it will return null to ptr. Okay, for, you can say, unsuccessful memory allocation. Okay, that means after writing this statement, if we say that ptr is equal to null, okay, then we say that unsuccessful memory allocation, as the memory is not allocated, then we will return. Okay, and other way around, अगर आप इसको memory इतना block मिलता है, then it will allocate memory of 10 bytes of 10 bytes to ptr. Okay, that means in ptr it will store the address of first byte in this memory, first byte of this memory. Okay, is it okay? Yes. Next function that we can use is calloc. Instead of using malloc, we